Hello, everyone. First, I would like to thank our kind host for the nice introduction and to thank all of you who joined our session today. During the session, we are going to show how SREs ensure reliability in complex, ever-evolving environment, and also how AI agents help SREs to work smarter and stay resilient. At the end, we'll wrap up with a live demo to bring up everything to life. Let's begin with a brief overview of our global site reliability engineering presence and the operating model. Site reliability engineering combines software engineering and system engineering practices in order to ensure reliability, performance, and scalability of production systems. It enables us to move quickly without compromising the stability and reliability of our services. Our SRE organization is operating across 5 strategically distributed locations, and in total, we are 12 teams covering 51 live services through a 24/7 operating model. This global distribution is intentional. It enables us to adopt the follow-the-sun support model, ensuring continuous coverage and empowers our teams for sustainable on-call practices. This structure not only enhances our response times, but also enables us to have a resilient approach towards achieving our broader objective, to deliver high quality and reliable services.
Hello from me as well. As all of you now know what SRE stands for, let's deep dive in one of our challenges, which we face in our day-to-day operations, and that's the cognitive overload. Imagine that you're an SRE engineer who is on call, and around at 3 at the night, a critical word comes in. You need to figure out what's going wrong, and you need to do it fast. But here is the catch. You're not working only with 1 or 2 different tools. You're actually working with 5 or even 10. Look at the slides where the SRE teams are connected to different set of tools. For example, Dynatrace, Elk, Thousand Eyes. These tools are powerful, yes, but when the engineer is in the incident at 3 at the night, he's context switching all the time, jumping between dashboard to dashboard, trying to correlate data manually, and to filter out all of the false positive alerts. We asked ourselves the question, what do we do to help the SRE engineer focus on what it actually matters instead of drowning in a sea of dashboards?
And here is the answer. That is where actually the idea of a Copilot powered by multiple agents comes in. And that's what we are going to explore next. As you can see, the chaos from before is gone. The complex mesh of tools connected directly to engineers has been replaced by an intelligent layer. At the core of the Copilot is a system of specialized agents, each one designed to emulate the expertise and workflows of a real SRE team. They are built to reflect real decision-making and responsibilities, but operate with speed, precision, and scale. Instead of having the engineer context switching at 3 at the night between tools and systems, these agents integrate directly with the entire ecosystem, analyzing alerts, correlating data, and provide possible root cause analysis. With this, the role of the engineer evolves, no longer overwhelmed with the previously mentioned cognitive overload. They are now focused on rapid incident response, root cause validation, and recovery during outage situations.
Let's take a quick step back to the slide with the teams and the tools. As SREs, we actually don't work only with tools. We work with each other as well, because sometimes the actual root cause could lie down in a dependent service covered by another SRE team. And this handoff, getting them into the context, sharing walks them to deep dive, introduces delays. Just adding one additional SRE team to the call can take up to 15 minutes, which in an outage situation, this is a lifetime. Now you can imagine when we need to add 2 or 3 teams. The time adds up, so does the risk. And here, again, the same question. What do we do to help this? As Peter already said, our agents, they're awesome, but that's not all of it. They're able to share context, knowledge, while working together in a collaborative way while the outage unfolds. Just like the real SRE teams, but without any delays.
And to understand how it really works, let's look at what makes up an agent. Each one is powered by 3 core components. Let's start with the context. This is the intelligent profile, which defines the agent's identity and its operational boundaries. Each agent knows what domain or services it's responsible for, what tools it has access to, what types of incidents it typically handles, and even its own personality and operating style, which is shaped by the practices and characteristics of the SRE team it represents. This contextual awareness allows the agents to act with precision. They know when to take the lead. They know when to support other agents and how to align with the larger incident response effort. The second core component is the toolset. This is the operational interface that gives each agent the ability to observe, analyze, and act. This includes, of course, direct integration with the previously mentioned systems like Dynatrace, ElkStack, Thousand Eyes, and many, many more. Agents can query real-time telemetry, inspect service health, and trace requests across dependencies. But beyond this static analysis of data, the toolset also lets the agents to take action. When needed, an agent can suggest a remediation step or fix, like restarting a service, draining the traffic from a bad node, or even rolling back a deployment. Every action happens within a human-in-the-loop process, so the interventions stay safe, visible, and under control. This keeps a balance between autonomy and oversight. Fast response with full accountability. And finally, the knowledge base. A rich blend of architectural documents, past incident data, dependency graphs, and procedural runbooks. That is from where actually the agents draws from in order to make informed decisions.
As SREs, we actually always get knowledge, tons of in fact, different runbooks, documents, everything. But if you remember the slide with the teams and the tools, again, it was a mess. So our next focus with the SRE Copilot was to turn this mess in something actionable. So we're introducing a separated component, so-called data loader, which is another component separated from the actual agent, and he has only one job, to combine all the documents and provide them as a single source of truth. To see the whole picture, for the one who you are familiar with AI, you maybe see that we are stepping up a little bit the things from using the normal vector databases, introducing a knowledge graph. That's simple as the vector database couldn't handle the cognitive overload which we had in our documents. And how does it work? We have a simple ingestion pipeline which creates all of the embeddings, re-rankings, it does everything for the documents. And then in the actual graph, we have the embeddings inside the graph nodes where all of the edges are semantically connected, so the agent could just query the information in a natural language. Here I can also share you one story from my years in university. It was like I was sitting in math lecture and it was like 5 o'clock, like just now, and I was not really paying attention. I was thinking, when I'm going to need this? Why I'm going to need this? Well, but the graph came with me at a vengeance, and that is just a small part of the graph which we had to handle in the SRE Copilot.
And all right, let's see all of this in action. In the demo which we prepared for you, our AI agents jump into the driver's seat. They will spot issues, coordinate responses, and keeping everything running smoothly without even a single SRE and service reliability engineer lift a finger. So let's jump directly to the demo now. So this is the interface. Give me a second. Maybe I'm not sharing the right screen. OK. So this is the interface of the Copilot itself. As we already mentioned, our target is to cover all of our teams represented with the specified agent. So here are all the agents which we currently have, which are named according to the name of the team. So I will start with this one particular agent. So I would like first to check whether it's OK as size of the screen. Is it visible and is it OK for all of you? OK. So I'll proceed. So what I'm going to do right now is to trigger a simple prompt to this particular agent. And what I'm going to check with it is what's the current state of healthiness of one of the most important services in SAP, which is a web-based control plane for all of the services part of the portfolio of the company. So I'm going to simply ask, please check the current state of the CF cockpit. So as you can see, one important detail, when I triggered the prompt, a process kicked in and actually executed an anonymization of my message, which actually ensures us that no user will be in a situation sharing sensitive data, and this data will end up in the large language model, because at the end, at the core of the system, we are using LLMs. So right now, the agent already responded, but I would like also to point out that at any time, we are able to track the process through which the agent actually fulfills my request. So here, this is actually the chain of thought of our agent. We are able to see, for example, in what language actually I asked him to execute a particular process or action. Then we can see that which tool actually the agent decided to use in order to fulfill my request, and of course the actual tool execution, the result of this execution, and the final response here. And at the end we receive this message, which luckily one of our most important services is up and running, and there is no issues. As I can see, a lot of my colleagues are here and they are calm. So during the presentation, we mentioned that the agents are able to collaborate and hand off tasks based on the context and their profile. And of course, the services for which they are responsible. I'm aware that another agent, which is namely this one, Mina SRE agent, it's responsible for another pretty important service part of our portfolio, which is called Web IDE. And it is self-explanatory. It's simply a web-based integrated development environment. So from this particular agent which we currently use, I'm going to ask the same question, but for this service. And let's see what will happen. Can you now check the status of the Web IDE? Again, at the beginning, it's almost the same. But the most interesting part right now will be exactly in the chain of thought, and where we will see something pretty interesting. As you can see, the agent already decided to use a particular tool, which is called handoff. And the idea of this tool is to provide the agents the ability to hand off tasks for which they are aware they are simply not capable to fulfill, but they know which of the other agents can help them. And that's exactly what's happening here. Similar to what Lyubomir explained, if we are not capable as a team to handle a particular issue, we are calling our colleagues and they help us to do that. So you see here, this handoff happened to the right agent, and here we can even see what's happening under the hood. So handoff has been executed because, give me a second to find it, because I'm asking for the availability status of Web IDE, and actually the agent which is capable to do that is exactly this one. And it's already executing that. You see, the other one already started working on my requests and already actually provided the state. And again, I'm really happy that everything is up and running as expected. So, unfortunately, for the purposes of the demo, of course, we are not able to break our productive systems, because right now what we see here is our productive systems, which are located on 40 data centers. Actually, in our organization, we are handling all that. And for the purpose of the demo, we introduced a dedicated agent, demo agent, simple name, which is, and together with that, we introduced a simple application. This application is a Python app which actually simply queries a database, PostgreSQL database. So at first, I will just trigger the same request to this agent. I would like to know what's the current state of my demo application. And I'm expecting that it will be the application to be up and running as expected, but let's see. The agent is doing its stuff, thinking, and as expected, the application is up and running. And the message also confirms that. So right now, I'm going to use this control plane, which explained previously during the session with the previous agent, and it's the cockpit. What I'm going to do here is to simulate an issue. And it will be simply related to that. Here is the demo application. I'm simply going to navigate to the instance of the database and will delete the key which is required for the application to be able to interact with the database. Without this key, the application will simply not be able to authenticate and use the database. So I'm going to delete it. Straightforward. So the deletion is already in progress. I'll wait a few seconds more. It's gone. And now I will ask the agent to refresh the state to see whether the agent is aware that there is an issue. And the same check will be executed, but the expectation is that the result will be completely different. And as expected, it is. the application right now is down because it's not able to connect to database and execute queries and operations related to it. Let's wait with the agent to finish, and of course, the message confirms what I just explained. And imagine that I am in a situation of an outage of one of our productive systems. I will be put in a call, and I need to act fast in order to resolve this issue. What's the first thing which I'm going to do? At least in my mind, the first thing which pops up is to check the logs of the application and see what's happening. For that purpose, I will trigger a command which will provide me an interface to extract the application logs, but not only extract and view them, but on top of that, my agent is going to analyze the logs and pinpoint the most prominent issues which actually which were observed. So I'm going to directly trigger the collection, and the logs were already collected. I can see them in a raw format here at the sidebar of the Copilot interface. And right now, the agent is executing analysis on that data. And I would like to see what's the issue, because right now I'm simulating, but in a real environment, I cannot be sure that I need to go and recreate the key in order to fix the issue with the database. This can be anything. And actually, that's what I would like to show you here. Let's see. The analysis takes some time. But at the end, we'll need to see the result and pinpoint the exact issue. And as expected, the first point which our agent identified is a widespread database authentication failures. We can see more details in the drop-down, but this will guide me that there is something unusual related to how my application is authenticated to the database, and that's why it's not able to work with it. So instead of going and recreating the key manually, imagine, imagine I am not aware about the issue and all the details around it. I am just aware that there is an authentication issue with the database. So what I'm going to check with the agent is, can you fix this issue for me? Let's see what will happen here. What will be proposed to me, at least, if not fixed entirely. And again, correlating back to the presentation. You see here the agent proposed to me to execute a recommended action. This recommended action actually is a related set of steps which needs to be executed in order my application to be up and running again. And as I said, correlating back to the presentation, the agent does not trigger it automatically. It waits for me to either confirm or to not confirm the execution of this recommended action. And of course, I want my demo application to be up and running again. That's why I'm going to confirm it right now. And the agent proceeds with the execution. It's executing the recommended action. We can observe it, of course, again with the chain of thought. And as soon as the recommended action is started, it's also checking the status, whether it will be finished successfully or we'll have an issue even with the recommended action. Let's see what will be the result at the end. So a lot of checks here, just polling the state. Right now, it's just polling the state of the execution of the particular recommended action. And we are waiting for the final response. So here is the final response from our demo agent. The issue has been fixed. The demo application is now up. And here we have also reference to the procedure which were executed in order this to happen. So I will check one more time the status in order to show it visually here in the interface. But it's already visible. OK, it already do that for me. Sorry. You see, we have the down state, and right now the application is back up and running as expected, able to work with the database. One more thing, I would like to show you also that the key were actually recreated for me, following the procedures for which the agent actually were aware, because it's able to check its knowledge base what actually is needed to be executed in order this issue to be resolved. And here you see the key is available. And at the end, while I'm in the call, the whole thread which we had with our agent, let's imagine that Lubo is together with me in the call, I would need to provide transparency, what actually I'm doing here, how I'm actually working on resolving this issue. I can quickly share the thread with him, and he will receive everything which I see here in the interface on his machine, and he will have the awareness. I just don't need to update each and every minute I'm doing this or I'm doing that. So, at the end, that was our demo. And as I see that we are already out of time, I would like to thank you for your time and your attention. And we'll be really happy if there are some questions or points for discussion stepping on this topic, to approach me or Lyubomir after that in order to discuss. These are the things which we demonstrated are a small piece of the capabilities which our Copilot has. So thank you very much.
Thank you.
All right, thank you guys again. As you said, we don't have time now, so you can reach out to Lyubomir and Petar after that. Now, this was the final session actually from this track. I would highly recommend you to join our last closing panel in the main track upstairs. It will be very interesting with interesting guests, so highly recommend to join us. Thank you guys.